Hi, we are Team B Menstrual, and for our senior engineering capstone project, we have been working to design a novel menstrual disc that will address the unique needs of women living in low-resource communities. It's no secret that women all over the world share the experience of getting a period. The average woman will spend roughly 6 years of her life menstruating, paying upwards of $6,000 for menstrual products during her life. In the United States, we are fortunate enough to have the infrastructure that allows us to make a quick trip from our homes to the nearest convenience store to buy a box of tampons. Nevertheless, the cost of menstrual products in the United States weighs a heavy burden on women from low-income communities, who often sacrifice education and work due to the high cost of tampons and pads. In low-resource communities across the world, such as communities in the Amazon and sub-Saharan Africa, the expense of menstrual products is coupled with lack of infrastructure, cultural stigma, and restricted educational resources, ultimately leading women to resort to unhygienic solutions that endanger themselves and affect their bodily autonomy. Currently, women in these communities use any available absorbent material to care for their menstrual cycles. Women use anything from a crumpled up piece of newspaper to cow dung to discreetly manage their periods. These solutions put women at high risk of infection and inhibit them from going about their daily activities, such as work and school. Therefore, women in low-resource communities need an accessible, effective, and sustainable method of caring for their menstrual cycles that better supports their quality of life. Because of the multifaceted nature of this problem, our group had to consider several distinct design requirements to create a solution that would address the entirety of the issue. Our first engineering design criteria was that the product needed to be accessible for low-resource communities, meaning that the product should be able to be transported into the communities cheaply and should be able to be efficiently packed in bulk to reduce the shipping expenses. Because many of these communities are extremely remote, the product would have to be brought directly to them through secondary health organizations, such as the Red Cross and other medical relief groups. Our second design criteria was that the product needed to be effective in collecting a physiologically relevant volume of blood for up to 12 hours, allowing women the freedom to go to school and work without having to change or clean the product in the middle of the day. Finally, our last design criteria was sustainability. Our product should be designed with the focus on waste management and should be reusable, giving women a tool that is environmentally sustainable. In addition, our team recognizes the importance of providing a supplementary educational component that would instruct women on proper use of the product through written and visual guidelines.
We created a pew chart based on our engineering design criteria and ideated several design options. We then used the pew chart design requirements to weigh the different options using a scoring system based on the importance of each requirement. As our team researched how these various ideas would be implemented in low-resource communities, we became increasingly more aware of how central empathetic design is to our mission. Our mindset began to shift towards creating a solution for women in low-resource communities that focused on fixing something broken and not just creating a novel and new solution. After reviewing the results of the pew chart, our team realized that each of the designs we had brainstormed would be compromising a significant requirement for the sake of novelty. We decided to take a look at the bigger problem at hand. We knew that the priority would be to provide women with a product that would allow them the freedom to go to school and work without being inconvenienced by their period. Even more, the research we had done showed us that alongside menstruation, rape and unwanted pregnancies was a reality many women from these communities face. For these reasons, we pivoted our design and selected a dual-purpose menstrual disc that would promote autonomy in menstruation and reproductive health. Menstrual discs would be considered Class II devices by the FDA. We had several design requirements, including biocompatibility, economical, and able to properly manage blood flow. We selected medical-grade silicone as the material for our product to satisfy the biocompatible design requirement. We also desired for the disc to be capable of collecting menstrual blood for up to 8 to 12 hours after insertion. This would make our disc competitive with other products on the market. To accomplish this feature, our final design iteration had an interior volume of 60 milliliters.
After this initial period of ideation, our team began to focus on the technical design aspects of the model. We performed several engineering calculations to solve for the disc's surface area, curvature, and overall correct anatomical placement. We used published statistics on average cervix size and radius for our calculations, keeping in mind that our product would need to accommodate a wide range of anatomical variability. These calculations led us to a concave lip design with an inner radius of 32.5 millimeters and an outer radius of 35 millimeters. Based on these engineering calculations, we were able to adapt certain elements of prior art to best fit our design requirements. We reviewed the current state of art for menstrual cups, cervical caps, and diaphragms, and combined relevant elements from each in order to create our novel dual-purpose menstrual disc. Overall, we focus on optimizing the disc's surface area to create an aesthetically less intimidating option for women who may be hesitant of insertion. The next step of the design process was to verify and validate design iterations in order to select the best features and materials for the model. We used SolidWorks software to model our design concepts in a 3D space. We created 4 molds of menstrual discs that varied in their rim designs. These molds were created using 3D printers in Tulane's makerspace. We purchased silicone materials of varying shore hardness from a company called EcoFlex. We poured each of these materials into one of the printed molds with the intention of evaluating which material and design combination would be most ideal for our final product. We then wrote up a testing protocol to test the different silicone materials with an ADMET device to quantify the viscoelastic properties of each material. We wrote a second protocol to test the necessary removal force of the device from the cervix with the intention of minimizing user effort and maximizing comfort. From speaking with our industry mentor, Ben Cappiello, we opted to add a curved lip to one of our SolidWorks designs. The curved lip would help stabilize the design internally and would also provide for an easier removal process.
While the next step in our design process was to validate our design using these testing protocols, our team was forced to shift and refocus after a COVID-19 disruption moved our class to an online format. While we could no longer meet in person to test our device, we could continue to improve our design through virtual teamwork. In summary, we selected a final design concept and created the Bloom disc. And due to our inability to physically test our prototypes, we decided to focus on the aspects of our final product that would be required to send it to market. One of these key aspects is an educational and instructional pamphlet that will be included in the packaging of our product. This pamphlet contains valuable information regarding menstrual health, menstrual hygiene, and instructions on how to insert and remove the Bloom disc. We hope the Bloom disc will give women the resources and confidence to manage their menstrual cycles, despite the challenges they face while on their periods. All women should be able to bloom where they are planted, and for these reasons, our team engineered the Bloom disc with a sense of female empowerment in mind. Team B Menstrual would like to acknowledge the people who made this project possible. Thank you to our incredible mentors, Dr. Catherine Raymond, Ben Cappiello, and Dr. Kristin Miller, for providing continuous guidance, for motivating us to set our sights high, and for supporting our vision for this project. We couldn't have done it without you. And for a final funding acknowledgement,